Okay, hello. Welcome to our first video lecture on statistics. This is one of 2 weeks that we'll spend on statistics and quantitative analysis, broadly speaking. So statistics is one of our major kind of research methodologies that we can use anytime we have numerical data. But as with our other methodologies, there's some nuances in how and when we can use statistics. And we're just going to cover kind of some very basic pieces of statistical analysis over the next 2 weeks. But I hope that we can kind of glean a sense for what can be done, broadly speaking, with statistics. And this is, in case it's not clear, again, this is a quantitative methodology. In fact, this is kind of quintessential quantitative. We're working with numbers now. This is going to build off the previous work that we did on surveys. So if you have not, and sampling. So if you have not seen the videos on survey and sampling, please go back now and make sure you spend some time with those, because this will be more difficult to follow along with without those materials. I'm going to go ahead and share my screen and get us started. Okay, so here we are in our statistics area. So what are statistics, right? Statistics is a word that we use, broadly speaking, to describe mathematical techniques to organize and manipulate data. So the word manipulate in there is not meant to be like, oh, we mess with it. It's just that we use different equations, basically, to figure out what some different things that data can tell us, can show us, that numerical data can show us. Now, luckily, today, we don't do that much of the mathematical work by hand anymore, right? I mean, people do, but a lot of this can be done. Maybe some of you are familiar. Some basic statistical work can be done right in Excel. That's what we'll be working in for this class. There are also programs that are specific for doing and running statistical analysis. So in other words, if you learn how to work them and put in the right keys, they will do all the equations and the mathematics for you. So some of you may be familiar or have used SPSS in another class. And that's kind of one example of a major program that can be used to do statistical analysis. But again, since we only have 2 weeks to spend on this, we're just going to be doing some basics, and we're going to be working with Excel. But before we even get into working with data itself, I'm going to continue going over some things that we need to know. I do suggest that you take your time with this video, maybe pause it, stop it, jot down some notes, cross-reference back with the reading so that you can be really clear on these core concepts, because they seem simple enough, but they do start to pile up and things get more difficult in the next video and in the next work if these things are unclear for you. So take your time here if you can. So in statistics, what we do is we collect data, or we use data that's already collected. We organize it, we analyze it, and then we interpret what it means. Okay, so you get the stuff, you get the answers to your survey, you download the census data that already exists, you organize it for yourself. And you're not going to be organizing data. I'm going to do that. And I'm going to show you what it looks like to do something we call cleaning data, basically getting it ready to do mathematical equations in the next video. Okay, just briefly, I'll show you what that means. Where that you then are going to analyze what's going on here, and that usually means running these equations, but again, we don't do much of that by hand anymore. And then you're going to interpret what it means, and that interpretation part that comes into play no matter what methodology you're using. Okay, what statistics can do is they can tell us, we have something called descriptive statistics that can just tell us some details about one specific variable, or we can look at the relationship between two or more variables. Remember that, we have all these variables that we're looking at on the survey that we used as an example previously, or on any survey. Each question usually represents its own specific variable at this stage. Okay, so we're working typically with a bunch of variables at this stage. Then you're going to pull out the ones that are important and interesting to you. So again, descriptive statistics, they basically can tell us more information about one individual variable. So that means if I ask, what is your gender as my question, and the attributes of that question are male, female, and non-binary, gender non-conforming, and that's a question in my survey, and I look back then at my answers and I look at the data, and 7 out of the 10 people that I sent a survey to answered female, then descriptive statistics is basically things like saying 70% of my respondents identified as female. Descriptive stuff, it can get more complicated than that, obviously, but basically I'm telling you, I'm putting the information that I got about one variable, the answers to one question, into kind of nice bite-sized pieces of descriptive data. Okay, more complex statistical equations can actually tell us about the relationship between different variables. So some of these equations can literally tell us how much impact one variable has on another. Or we can at least look at, do they correlate? Do they both go up at the same time? Do they both go down? Are they stagnant? Does it seem random? So those again, we're not going to actually run those types of equations in this class, but I want us to be aware that statistics can tell us some really detailed information about the relationships between variables. Okay, as a review and a reminder, variables are these kind of units that we're using, kind of a trait that can change values from case to case. In our case, in our universe right now, our variables for the purposes of these couple of weeks are going to be drawn from the survey of Mercy College students that was conducted by a previous class, and which I will have up on your screen, definitely in the second video, and maybe a little bit today, we'll see. As a reminder, remember what we use as independent variables are the causes or existing conditions, and dependent variables we usually think of as like the effects in a cause-effect relationship, and they're usually manipulated or they're influencing, they're influenced by the independent variable. One thing that you'll need to think about if you were to sit down and look at data to do statistical analysis is, what is the level of measurement for each variable? And each variable is going to be different. There are basically 3 levels of measurement that we'll talk about in this class. The level of measurement as a term, this means it's basically characteristics of the variable that can affect the statistical methods that you're able to use. Okay, and I think that will become clear as I go through what they are. It's a little bit abstract right now, but I'm going to give you those 3 levels of measurement. Okay, and you need to, the first thing you'll need to know is what is the level of measurement of a variable that you are trying to work with. Okay. All right, we're going over 3 kind of groupings of levels of measurements, 3 levels of measurement. The first level of measurement is nominal, okay? Nominal variables are usually non-numerical, and they're the type of variables that are exclusive and exhaustive. So if you were to visualize this, how you could map out the answers to nominal variables, it would be something like if you have to fill in a multiple choice question and there's only one option that you're going to be able to fill out. Typically nominal variables, they can't be quantified and they can't be ranked. Usually, like they can't be, it's not a lowest to highest situation. They're just different, right? Any variable where there's just different categories. So gender would be a nominal variable, drawing off the example I used before, because the answers there are female, male. Maybe you have a category that says gender non-conforming or non-binary. But either way, even if you have a category that says other or prefer not to answer, either way, what everybody has answered is a discrete kind of separate category, and you can't rank them, right? It's not like you can go highest to lowest with gender, right? They're just different. They're not numerical, so you can't like add them up and find the average, right? Of the numbers you can, but you can't add up you can't quantify the difference between male and female. Okay, the examples on the screen, you see also race is typically a nominal variable. So that's something like, you know, Black, white, Latino, Asian, mixed race, etc. Again, no, even if you have different categories than that, this would be typically used as kind of, you can't quantify them, you can't rank them, you can't line them up from lowest to highest, and you can't quantify like the difference between one or the other. Okay, religion is another example. If you ask the survey question that says, what is your religion? And the options were Protestant, Jewish, Buddhist, Muslim, etc. You know, whatever other answers you had available, even if you had like an other or prefer not to say category, this would be a nominal variable. Nominal variables, you cannot add them up, you cannot quantify them, you cannot rank them from highest to lowest, best to worst, quickest to slowest. That's what a nominal variable is. Okay, yes or no questions are also often nominal. Any sort of like, do you attend Mercy College right now? Yes or no. That's typically a nominal level of measurement variable. Okay. The next level of measurement is ordinal. Okay, ordinal variables are also typically not numerical in the sense that you cannot add them up and necessarily, but they are scores that can be ranked from high to low or more to less. Okay, so if I asked about socioeconomic status, working class, let's say I did working class, middle class, upper class, I can't exactly quantify the differences there, at least with that formation of the question, but I can kind of rank those, not in terms of best to worst, but I can rank them in terms of kind of least wealth to most wealth. So I can see there's some sort of order there. So of course the word is ordinal. So if you feel like there's some sort of order there, that usually works. Another example would be if there's a question on a survey that says, what is the highest degree that you have completed? And a lot of times that goes less than high school, associates, some college, bachelor's, whatever, master's and beyond. So you can't totally quantify the difference between these, but you can kind of rank them in terms of least to most number of schooling. So anything you can kind of rank from one end to the next or put in some sort of sensical order would be an ordinal variable. Okay, opinion questions also tend to be ordinal. And that means, you know, anything that says, do you support this policy? And it's like strongly disagree, neutral, agree, strongly agree. Those are pretty much always ordinal, right? Because there's an order that makes sense in those, but you can't like add up the difference between strongly agree and agree, right? Okay, so ordinal is anything that it's not necessarily totally numerical, but it can be ranked. Another example of this would be something like class rank or class year. So if I say, excuse me, what year are you at Mercy, roughly speaking, and people might answer freshman, sophomore, junior, senior, and we could then say, you know, year 1, year 2, year 3, year 4. Even though I can put numbers there, those are still typically an ordinal variable because they're somewhat separate from each other, but I can put them in a sensical order. Okay. The next level of measurement, these are actually, they're related, but we're going to smush them. They're a little bit different, but they're related. So we're going to smush them together. And these are interval or ratio level of measurement. For our purposes, interval ratio variables are going to be anything that can be ranked, just like ordinal could be ranked, but also that the distance between categories can be clearly defined. Typically, this is stuff that we get an actual numeric answer for, okay? And we can somewhat see that there are what the intervals between categories are. Even if this is a little confusing, but they don't have to be exactly equal, but we do have to understand what they are, right? So if I ask, what is your age, and just have people write in the answer, we know the time difference between age 1 and age 15 is 15 years, right? And age 15 to 22 is 7 years. So anything typically that people answer with a number, as long as it's not like an opinion question that's ranking from 1 to 5 or something, because that's different. But anything that people answer with a number, like how many children do you have? This would be an interval ratio measurement. What is your income? Asked in that way where people can write in a number, that can be an interval ratio measurement, which is different if we remember from asking something like, what social class do you most closely identify with, right? Because the way that question is asked, I can't quite add these up and find the average, right? I can order them, but I can't exactly quantify the difference between working class to middle class or middle class to upper class. Okay, so a check-in here, this is going to be in your Blackboard for you to answer and give some questions back to. If I and so you might want to do that right now while you're watching this video. If I ask what levels are these, like what level of measurement makes sense for these variables? If I'm going to have a question on a survey that says, what is your marital status? Usually the responses to that are going to be single, married, divorced, separated, something like that. Okay, so think about what level of measurement would that fall into? Would it be nominal, ordinal, or interval ratio? Zip code. Zip code is a tricky one because when I ask zip codes, they are numbers, right? But think about what we use zip codes to represent and try to think about whether or not that's nominal, ordinal, or interval ratio. Keep in mind that if I say my address is 10467 and my mom's address is 11211, I can't add those up and quantify the difference, right? So zip code, even though it's a number, it's really functions more like a neighborhood kind of name or title. Okay, if I ask you how many siblings do you have and allow you to write in the answer, what level of measurement would that variable be? But then if I ask you what is the birth order? Where are you in the birth order amongst your siblings? Are you first, middle, or last, or maybe only child? Then what might that be? Okay. And then if I ask you an attitude or opinion question, how do you feel about this new piece of legislation? Strongly disagree, neutral, agree, strongly agree. What level of measurement would that be? Okay, so go back and give me your answers to those, and that's one of the things you're going to submit for the lab this week. Okay, a few other things we need to be familiar with going forward. One, when we're describing variables, when we're talking about the type of data that we got, if you see the letter N, N refers to the number of cases in a sample. In other words, how many people did I get to fill out my survey, right? So if I know that we did this survey of Mercy College students, but I didn't talk to every single person, right? In fact, I'm looking at what was the number of people that I actually got to respond, and that would be my number of cases. So I believe in the survey that we're kind of referring back to, the N was either like 89 or 90. Okay. The frequency, I'm going to skip. I do not need you to know that at this point through this class. Okay, we should be aware of the difference between a population and a sample. In the example that we're working with, the Mercy College survey, the population we're referring to is Mercy College students. The sample is those 89 or 90 people that filled out the survey. Okay, so in general, the population is like, what is the big group that you're referring to when you work on a proposal? Maybe your population is neighborhood residents in these 3 zip codes, but you're not going to do a survey of every single one of those people because that would be impossible. So your sample is going to be what the 200 people that you are aiming to get to answer a survey. Okay, and remember, we have sampling techniques for how you get that sample. Okay, we saw this slide already, but it's here again. Your level of measurement, don't forget about that. Now, remember levels of measurement, we had nominal, we had ordinal, we had interval ratio. And I said that the purpose of understanding what the level of measurement for your variable is to know what kind of statistical equations we can and cannot run. So for our purposes, what we're going to be focusing on in this class is just measures of central tendency. Hopefully, I would think some of us are familiar with these terms, right? Remember the mean, median, and mode, it's back. Many of us probably looked at this in high school math at some point or another. Basically, these are all mechanisms to tell us about the basic distribution of scores or responses to a given question. So the phrase we use to refer to these is measures of central tendency, ways that we measure the stuff that falls in the middle of a category somehow. Okay. The mode refers to the most common answer. Okay. So the mode refers to the most common answer, right? Write these down, take a minute to jot this down, pause the video, whatever you need to do. The mode just says which bubble was the most filled out in this survey. Okay, and we know that can tell us some things, but it's a little bit limited in what it can tell us. That's the mode. The median is if I lined up all the answers, right? If I listed them out, what would be the one that falls in the middle in terms of my responses, right? So if I took the time, and we don't do this by hand anymore, but if I took the time to lay out every response to a question, which response would be the one that fell in the middle? And finally, the mean is what we think of traditionally as the calculated average. That means this is the one where we add everything up and divide it by the number of responses, right? So we do this every single semester typically. This class actually works a little different because you just get points, but a lot of times you get, 100 on your first test and then 84 on your second test and a 96 on your third test and a 95 on the next test, right? They're going to add those all up, then divide by 4, and you're going to get your average, assuming that each test has the same amount of value for your grade. So we're familiar with the mean, right? This is kind of the traditional, the average score. Okay. Now, why am I bringing this up? Because the level of measurement of each different variable tells us which of these measures of central tendency we can use. So for variables that are nominal, we can only use the mode. Remember, nominal was the one that there's just discrete values that you can pick. So that's something like gender, race, what is it, my other example? Religion in there, right? People fill out their answer. And all I can really tell you is what was the answer that was chosen the most, right? I can't rank them, remember, so I can't tell you what's in the middle because there's no way to rank, religions from top to bottom or even from side to side. All I can tell you in terms of measures of central tendency is what was the most common response. Okay. Ordinal variables can use the mode, excuse me. So they can also tell you, I can tell you what was the most common response, and I can tell you what was the median response, what fell in the middle. So if I asked a question about beliefs and attitudes, right? Strongly disagree, disagree, neutral, agree, strongly agree type question, I can tell you the most common answer was strongly agree. That might be my mode. But then if I line everything up, maybe a ton of people said, the most people said strongly agree, but then a lot of people were dispersed between neutral and disagree and strongly disagree. And I'm going to wind up having my median, whatever's in the middle, be something else, be agree or be neutral. Okay, so ordinal can use mode or median. Interval ratio variables can use all three. So with interval ratio variables, I can tell you the mode. Typically, I can tell you what was the most common response. That tends to be not super useful for interval ratio variables, but it can be. I can tell you the median, like I lined them all up and I picked the one in the middle that fell in the middle from however it's ranked, lowest to highest, best to worst, or some sort of order, earliest to latest, whatever. And I can tell you the traditional average. I can tell you the mean. So that's something like, what if I ask, what is your age? And then I add up all the ages of all my respondents, and then I divide by the number of respondents, I'm going to get the average age for respondents in my study. Remember, you cannot do this with even something like attitudes and behaviors, right? Because if I'm looking at strongly disagree, disagree, neutral, agree, and strongly agree, I could assign a number to each of those, 1, 2, 3, 4, 5, and try to do some adding and dividing with that. But if I come out with a 2.3 average, that does not tell me anything because I cannot quantify the difference between disagree and neutral, which is where that would fall. Okay, so it's critical for each variable to be able to identify what is the level of measurement for that variable, and then think about, okay, given that, what measures of central tendency can I use to try to communicate some nice factoids and tidbits about this variable, some descriptive statistics. Okay, that's it for week 1 of statistics. Again, I urge you to take some time with this and really let it marinate a little bit, do the reading, do some of the practice, and then we'll come back to statistics in the next video, and we will look at some of the data that we'll be working with. And that's that.